Today, my esteemed colleagues and I will be going over the details for Experiment 2, Fluorometry. In this instructional video, we'll be talking about the theory, the procedure, and the techniques that you need for this lab. Basically, minor details. So please try to pay attention. I know it's early in the morning, but just try to stay awake for, 10 minutes at most. If you've been paying attention since class began, about a week or two ago, you know that basically when energy is absorbed by certain complexes, their electrons are promoted to higher energy levels, and that basically they'll release energy in the form of light and they'll return back to the ground state. Now, this phenomenon is known as fluorometry. In the case of this complex, there's two fluorophores which are in close proximity to each other, and instead of giving off energy as light, they basically give the energy to other surrounding molecules. This is known as fluorescence self-quenching, also known as FSQ.
This is an overview of the machine we will be using to measure the fluorescence of our samples. To open the loading tray, press the eject button shown by the upper arrow. When the door opens, your plate should fit right into the loading plate slot. When you're finished loading your plate, press the eject button again to close the door. This diagram shows how the FilterMax machine will measure the absorbance of our samples. The X in the blue circle represents the LED rotator that releases the light. The blue dotted line represents the path of the light. The light goes through the blue box, which is the filter, and is reflected through the collimated lens, which is represented by the white circle. This lens concentrates the light at the sample, and when it passes through the sample, it hits that little yellow circle, which represents a silicon photodiode. This photodiode sends the information to the computer for us to use.
Hello everybody, we have ourselves the wonderful dieosin glutathione disulfide molecule right here. It consists of two glutathione molecules here and here that have been connected through a disulfide bridge right here. We also have eosin, which is here and here. This eosin molecule is over here. This is what creates our fluorescence in this molecule. We can see that because the large conjugated system in this molecule is what gives us that property. Now, back over here in our dieosin molecule, this does not give off any fluorescence. This is due to the close proximity of eosin in fluorescent self-quenching, which Adam spoke about earlier. So we need to separate these two molecules by cleaving this disulfide bridge. That's where my handy-dandy thiolate comes in, attacks, which erases this disulfide bridge, and now we have two separate molecules. Where do we get these thiolates, you ask? Well, they come from thiols, which my esteemed colleague Adam will now bring in. So we see we have our four thiols here. We have dithiothreatol, homocysteine, glutathione, cysteine. As we can see, and I'm going to use cysteine as my example, we have the SH here of the thiol. In our reaction, we need to lose this proton. We know that the pKa of cysteine is 8.0. So we're going to use a buffer system to create our pH around 8.0, and that will have this part deprotonated so we can attack that disulfide bridge. And that, ladies and gentlemen, is what's happening in our lab today.
Hello, my name is Mike, and I'm going to talk to you guys about the procedure part. And this is the plate reader. You're going to set up the plate reader in fluorometry mode. The parameters are already set. Each group will get two known thiol, either DTT, homocysteine, cysteine, or glutathione. We're going to make 6 concentrations of 1 milliliter thiol solutions for each thiol. We're going to add 160 microliters of the thiol dilutions into each well in duplicate. We're going to place it into the plate reader, and quickly we're going to add 40 microliters of the dieosin glutathione disulfide solution into each well. We're going to close the plate reader quickly. and press read. So in this case, you're not doing a reference because you are actually doing acceptance. From part 1 in the procedure, you will get a standardized curve for the 2 diols. Your 2 unknown diols should fall in between the curve, the concentrations.
Good.
Okay. For part 2, it is the same procedure as part 1. The only difference is you are going to be using 2 unknown diol concentrations, and you will be placing them in triplicate instead of duplicate into the well plates.
We'll be working in a matrix of 6 by 6. The thiol solution will already be in the plate, and you're going to add the di-eosin glutathione disulfide with a repeat pipetter as quickly as possible. Now you're going to make sure that you add to each well and not beside the well. Also, you're going to have your lab partner keep track of which well you've added so that you don't repeat adding to the same well. Now, Nick will show you how the repeat pipetter works.
So this is a repeater micropipette. To use it, place your index finger in the groove and put the repeater tip into the notch here until you hear a click, and lower the lever. Then add the pipette tip to the end. To standardize it and get rid of all the air bubbles, lift the lever up and down 3 times, and then bring it all the way to the top. And to release the liquid, quickly press down on the top lever and make sure that you leave a few microliters in the bottom so you can have proper measurements in each of your well plates.
Here are a few hazards to be careful for when you're doing this experiment. Number 1. Thiols in large concentrations are toxic if you inhale or swallow them, so keep these compounds under a fume hood. Number 2. Eosin is a suspected carcinogen, so when you're dealing with di-eosin glutathione disulfide, be careful. And number 3, to avoid any irritation from chemicals, wear goggles and safety gloves. And just as a quick reminder for this experiment, make sure that you keep the thiols under the fume hood. When using your repeat pipetter, go quickly. Keep track of your dilution factors, and make sure you bring a USB stick to save your information. Good luck!